Hello and welcome. In this video, we're going to solve a couple of integration problems starting from the basics. Alright, so whether you're new to integration or you're not new to integration, you're definitely going to learn something from this video. So stick around to the end, hit the like button, hit the subscribe button, and let's get started. Alright, our very first question is to evaluate integral 3x² dx. Alright, so how do we evaluate this? Okay, we have to remember a very simple law that says whenever you are evaluating an integral, right, you add 1 to the power and then you divide by the new power. Very simple. Okay, so in this case, we're going to have 3x to the power 2 plus 1 divided by 2 plus 1. Okay, the new power is 2 plus 1. Right, so we're going to have 3x to the power 3 divided by 3, and this is equal to x cubed. Now, whenever we are integrating, we have to add plus c. Why are we adding plus c? I'm going to explain during the course of the video. Alright, so this is simply how you solve this problem. Now, this integral is with respect to x. That's why we have dx. In case you're wondering what this dx means, it means you are differentiating with respect to variable x. So if I have another variable, say 3t squared, right, it is going to be with respect to t. Okay, so I'm going to be integrating with respect to t, so it will be dt. So that is simply that. So let's move on to another question. Alright, so the next question is to evaluate 9x cubed plus 7 dx. Alright, so how do we integrate this? Just like we did before, we add 1 to the power and then divide by the new power. So this becomes 9x to the power 3 plus 1. The new power is 3 plus 1 plus 7. Now 7 has a variable x to the power 0 because x to the power 0 is 1. So 7x to the power 0 is the same as 7. So you add 1 to the power, right, divide by the new power. Alright, so it becomes 7x to the power 0 plus 1 divided by 0 plus 1. And this becomes 9x to the power 4 divided by 4 plus 7x, right, plus c. Okay, now take note of something. Whenever you integrate a constant, right, it doesn't have a variable x with it, so it's a constant. Whenever you integrate a constant, just simply multiply it by the variable to which the integral is with respect to. So this integration is with respect to x. Okay, so you simply multiply the constant by x. So if I'm integrating 20 with respect to x, my answer is simply going to be 20x. Very simple. If I'm integrating 55 with respect to x, my answer is simply going to be what? 55x. Alright, so when you're integrating a constant, just multiply by what the variable to which the integral is with respect to. Very, very simple. Alright, so integration is the opposite of differentiation. So if I have a function, say y equals to 2x cubed plus 5, right? When I differentiate this function, right, to have the y dx to be equal to 6x squared, right? This is what the derivative. Now, in order to go back to the original function, I have to integrate. Okay, so in the process of integration, the purpose is to go back to the original function. So when I integrate both sides, with respect to x, I'm going to have this integral dy dx to be y, okay, and that is going to be equal to 6x cubed, add 1 to the power, right, just like we've done earlier, and divide by the new power, right, 2 plus 1. So that's what 6x cubed over 3 plus c. Okay, so this is why we're adding plus c, because there could be a constant in the original function. Alright, so this becomes 2x cubed plus c. Do you get it? So let's move on to solve more problems. So we know that in this case, our c is equal to 5. Alright, now let's move on to solve more problems. Alright, we have evaluate integral 2 root x minus 1 over x squared dx. Okay, so in this case, what we do first is to simplify. To simplify our integral, we can have this written as the integral of 2x to the power 1 over 2. Right? The square root of a variable is that variable to the power half. Right? So 2x to the power 1 over 2 minus, we can rewrite this as x to the power minus 2. Right? Dx. Okay, so now we can add 1 to the power and divide by the new power. So this becomes 2x to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 minus x to the power minus 2 plus 1 divided by minus 2 plus 1 plus c. Alright, so this becomes 2x to the power 3 over 2 divided by 3 over 2 minus x to the power minus 1 divided by minus 1 plus c. Okay, so you can rewrite this as simplifying. You can have 2 multiplied by 2x to the power 3 over 2 divided by 3. So I just brought the 2 up, right? You can simplify. This should be easy one for you to simplify, right? You can pause the video and simplify it. Alright, so minus divided by minus plus, and then we have x to the power minus 1, right? Then plus c. So finally we can conclude that our answer is 4x to the power 3 over 2 divided by 3 plus, we can rewrite this as 1 over x plus c, and that is it. Very, very, very simple. Alright, so here we're to integrate sine x, integrate cos x, integrate sec²x, integrate sin x, integrate cosh x dx. Alright, so when you know one, you basically know the rest, right? And from your differentiation, you can actually know what the answer will be for the integration. So if you recall from differentiation, you know that when you differentiate cos x, you have minus sine x, right? So when you differentiate sine x, you have cos x. Okay, so in this case now, when you integrate sine x, it's going to be the opposite, right? So you're going to have what? Minus cos x plus c. Okay, and put the dx here. When you integrate cos x, dx, it's going to be the opposite, right? You're going to have sine x plus c. Very, very simple. Okay. Now, when you differentiate tan x, you have sec²x. And I've actually done a video on this, right? You can check. I'm going to put the link to the video somewhere in this video on your screen. It will be showing somewhere on your screen right now. You can check it out. I explained how differentiating tan x gives us sec²x. So just know that when you integrate sec²x dx, you are going to have tan x plus c. When you want to integrate sin x dx, this is an hyperbolic function, and basically it is just going to be the opposite, right? So when you integrate sin, you have what? Cosh x plus c. And when you integrate cosh, you just have what? The opposite, sin x plus c. Very simple. Very simple. So that's it. Our next problem is to evaluate the integral of 1 over x dx. Alright, so for this problem, our answer is simply ln x plus c. Okay, so the law is that whenever you want to integrate a function, and you observe that the derivative of the denominator gives you the numerator, the answer is going to be the ln of the denominator, alright, plus c, the integral of that entire function. Okay, so let's take a look at another problem to make it stick to your head. Alright, so I can see that when I differentiate my denominator, right, I'm going to get my numerator. Okay, so you can pause the video, differentiate your denominator, you see that you get your numerator. So that means the answer to this integral is simply the natural logarithm of the denominator, which is x² plus 3x plus 5 plus c. Very simple. Do you understand? Alright, our next set of problems are to evaluate exponential x, exponential 5x, and the integral of 5x minus 4 to the power of 6, all with respect to x. Okay, so basically, the integral of exponential x is equal to exponential x plus c. Just like when you differentiate exponential x, you get exponential x. When you integrate exponential x, you also get exponential x. Now, when you integrate exponential 5x, this reminds us of function of a function, right? So we have a function exponential x, and then we have another function, which is what? Exponential 5x. Okay, so in this case, we are going to be doing two things. We are going to be differentiating, and we are also differentiating and we're also going to be integrating. Alright, so these are the two things we're going to be doing in this case. So I want to look at my exponential 5x as a function of a function. So I'm going to say that 5x is my inner function, right? And I'm going to say that the entirety, which is exponential 5x, is my outer function. Okay, so basically, just like the process was when we were differentiating a function with a function, if you want to brush up on differentiating a function of a function or chain rule, using chain rule, you can check out my video on that. I'm going to leave the link in the description below. Alright, so basically differentiating. So let's say we want to differentiate exponential 5x. Okay, so what we do in differentiating is what? Differentiate the inner function, right, to get what? 5, and then multiply it by differentiating the outer function as a single function. So normally when we differentiate exponential x, we get what? Exponential x. So if I'm differentiating the outer function as a single function, I'm going to have what? Exponential 5x. Okay, so that is basically the same process, but in this case now we are going to differentiate and then integrate. Okay, so differentiate first and then integrate. So we're going to differentiate the inner function, which is 5x, and the difference here now is in integration we are dividing, in differentiation we are multiplying. Okay, so we multiplied what? 5 by the outer function after differentiating it. Okay, so in this case we're going to divide, so I'm going to write this as 1/5. Okay, and then we are going to integrate the outer function as a single function. So we're now going to integrate exponential 5x as if we are integrating exponential x. Do you get? So now integrating this gives us the same thing, right? So gives us exponential 5x plus c. Don't worry, you're going to understand when we solve this problem. Okay, so if we want to integrate exponential 7x, for instance, this becomes what? 1/7, right? Exponential 7x plus c. Alright, so let's solve this problem C. So the first thing we established is that this is a function of a function, and we are doing two things. We are differentiating and we are what? Integrating. Okay, so we also established that we are calling this inner function. We're calling this function our inner function, that is 5x minus 4, and we are calling the entire question, right, our outer function. Okay, so basically we differentiate what? The inner function, and then we integrate the outer function, right, as one function. Okay, so when you differentiate 5x minus 4, we are going to have what? 5, right? So in integration, what we do is what? Divide. So we have 1/5. Okay, and then we integrate. So just like you integrate x to the power 6 as add 1 to the power divided by the new power, that's the same way you're going to integrate with 5x minus 4 to the power 6. Do you get? So that becomes 5x minus 4, right? Add 1 to the power 6 plus 1 divided by the new power 6 plus 1. Okay, so this becomes 1/5 5x minus 4 to the power 7 divided by 7. So you multiply the denominators, you have 5x minus 4 to the power 7 divided by 35. Very, very, very simple. Thank you very much for watching. We have come to the end of the video. Don't forget to like, share, subscribe. See you in the next video.